So I'm Sylvie Louisy. I'm not a biologist. I'm a citizen, whatever. I'm just a normal person, I mean. Well, I'm going to talk about this. What can individual photo identification tell us about seahorse biology and behavior? A 5-year survey. It's just that it's in our backyard. So as we are often diving there, we started to take photos of them. So it was in the Thau Lagoon, so now you know where it is. That's France, and Thau Lagoon over there. With the area we've been sampling is a very small area, about half an hectare, divided into quadrats, so we can localize the seahorses we've been identifying. You can see that, well, during those years, we found quite a lot of seahorses that have been individually identified, that we collected lots of photos, and, well, we had lots of observation. So I'm going to talk about the protocol. First thing is underwater. So we take pictures of both head profiles, and another very important picture is the one on the slate, to have for measurement. Other information are collected on a slate underwater. Well, I must say that most dives are done at night because it's much easier to see them at night. Then photos are compared with selectric portraits of already recorded individuals. So, well, that's female right profiles. You have left profiles to compare. And, of course, we have males, both profiles, and unsexed juveniles, too young to be sexed. And, well, this is an example of annual summary table. So you have individuals, dates. Each box is a sighting. The first sighting in red and new sightings in yellow. Seahorses can vary a lot in aspects, so it might be hard to identify them, but we have some clues that we've learned, like the size of the seahorse as we measure them. Well, it's the first clue. And then there's the shape of the nose spine, which is very specific. The shape of the cheek spines, the head and dorsal filaments, which are quite constant, which was unexpected. And of course, the most important is the white markings on head, especially the one around the eyes. And for me, who is doing that job all the time, for this one, if I can find, well, I can't. So it's this horizontal line is very unusual. You might not know, but it is. And this oblique line is very unusual. So I could know it was this one immediately when I saw those lines. Then we check with the other profile to make sure that it's the same. So it's okay with this one. So despite variations, ID is still accurate. So here you have variation according to breeding season. I have no time to explain. Variation with seasons, variation with age. So this one, 4 different years, the same individual. And variation in color. So color is not a clue. So then the first use of individual photo ID is to count seahorses, and that's why we did it at the first time. We were very curious to know how many seahorses there could be in this place. So you can see that underwater visual clearly underestimates the population size. You have in red the lowest number of AGU seen in one dive. In blue, the biggest number. In green, the average number per dive, and in purple, the total number of identified seahorses per year. So, as you can see, there is a huge, tremendous difference. So, the data we use by sighting, resighting, are similar to the capture, tagging, recapture data used to estimate fish stocks in fisheries. So they can be analyzed with the same kind of model. That's what Olivier Gimenez from the CEFE Montpellier is still doing he's still working on it, so we don't have all the data, but we can already compare, and that's the yellow bars, that it's the same order of magnitude as the total number of individuals identified per year. But I think it won't be the same for 2022, and I will explain this to you later. So we've learned things about reproduction and breeding season. You have in red, it's a temperature curve, sorry. And in blue, it's percentage of pregnant males among males. Well, it's not a huge surprise to see that the pregnancy follows the temperature graph, the temperature peaks. But something happened in 2022 that you can see here is that the breeding season abruptly stopped in August, and well, because of a heat wave, and I'll talk about it later. We also managed to collect lots of growth data that you can see here. The dotted lines are males, the other ones are females. These are examples of 24 juveniles. These green spots are the pregnant males. And you can see that they start breeding at very small size, even smaller than the one we can see on the graph, because we found males 9.2 centimeters already being pregnant. Baby seahorses, which recruited in spring, early June, are able to reach 12 centimeters or more within the same years, while the one that recruited late, September or end of August, most often stay small during all winter and even early spring, and they have their main growth, they are the one in blue, the next summer. So we also collected very long life growth curve. So that are the individuals that were repeated at least for 3 years. And we can see that long-living males can breed for 3 consecutive summers, as long as they're alive, in fact. And you can see that some specimens reached unexpectedly high sizes for the top population. This line is 10 centimeters. Over there, it's 15 centimeters. So the one in pink can reach almost up to 18 centimeter total height, while others, living as long, didn't even reach 14 centimeters total height. The most important growth in red is during the first summer, but they keep growing during their subsequent summers and all their life long. They seem to be getting smaller at some time in their life. It's just that, measuring them on a slate underwater is not always very accurate, so we can have a few millimeters difference. Well, now I want to talk about the effect of year 2022 heat wave on the seahorse population. So here you have, I'm a bit lost. So the curves are the temperature it's only in 2022, during the months of June, July, August, September, and October. The bars are what we saw at each dive, and when there is a gap, it's just that we were on home and we didn't dive. So, unfortunately, during the worst heat wave, we weren't there. What you can see that there were 2 successive heat waves, one in July with no obvious impact, and one in August with a tremendous impact. So when we came back, we saw that almost all the adult population has disappeared. Only 2 identified adults and 1 juvenile were still found. So the breeding season abruptly stopped. And the catastrophe was followed by a huge bloom of juvenile recruitment. So I forgot to tell you, but in blue, it's the male. Dark blue, the breeding male. In pink, the female. And in green, the juvenile. So here you can compare with what happened during the 5 years we've been studying, measuring seahorses. So each curve is a year. 2022 is the red curve, and you can see that the percentage of juvenile under 10 centimeters was really huge and tremendous, and that we've never witnessed any event comparable to the 2022 juvenile bloom. But what happened the following years? So in 2022, we had high mortality and then high recruitment. But if you look at the column, at the bars, sorry, you can see that in 2023, it was the lowest recorded number of seahorses found in the lagoon, in the site. But still, they are still there. I mean, not all the population disappeared. And, well, this is my favorite graph. So you have lots of waves. Well, in fact, we have data since 2018. So this in blue are the new one recruited in 2020. So they're still there here and still there in 2022. You have in yellow the new one recruiting in 2021, and you see they're still there in 2022. In red, it's this huge recruitment we had in 2022. And you can see that in 2023, there's only 2 generations together. That all the seahorses we found, the older ones, were from 2022, and most of them were quite small, were very small individuals. But then, what happened is that now, last year, in 2025, we had for the first time 4 generations together, with seahorses from 2022, 2023, 2024, and a very low recruitment of seahorses from 2025, the lowest we have ever witnessed. So, well, the population is aging, that's what we thought, and this is, we can see it here with the evolution of size distribution. So, well, in blue, you have the seahorses under 10 centimeters. In orange, the one under 12 centimeters. In purple, under 14. In green, under 16. And in red, up to 18.
2 minutes left.
Okay. So you can see these waves that, well, in 2022, we have lots of small individuals in the site, but now they're getting much bigger. And for the first time, the one more than 14 centimeters are prominent in the site. That's an increasing proportion of individuals bigger than 14 centimeters. So to summarize, by identifying individuals, we could get data on color pattern and morphology, population estimates, reproduction, growth and longevity, resilience and response to climate change, but also to site fidelity and movements, which I don't have time to talk about, and to habitat use and hold fast and so much left. So, well, that's it. Well, it's finished. I have much more, but, well, no real time for it. So you won't see it.
2 minutes left.
Well, let's see about that. Just to show you that most of them are sedentary, as we know where they are. Like this one, who's been staying in the same place for 3 years. It was a female. I know her by heart. I recognize instantly when I see it. Most of them move a little bit, but some of them have been doing quite a huge move. And what's interesting is that this one, which is one who survived the heat wave, it was there at the beginning, and then it moved over there where we found it at after the heat wave. And after 2 years staying there, we found him back here, where he was at first, last year. Well, then it disappeared. This one is showing that the population is also, it seems to be moving. So it used to be mostly in this place where there is a jetty. And I think that's what happened last year. Last year they moved north of the jetty, which is, well, quite a surprise. We really don't know why. And, well, this is just quick to see something that they also seems to change habitat. So they used to like very much being on concrete structure, and suddenly they moved to rocks. So we used to find them mostly on wrecks and concrete structure, and they've been going to rocks. They also moved to seagrass, but because there were seagrass. But when there weren't so many seagrass at the first, in 2021 and 2022, and then the seagrass beds increased, and we found more and more of them in there. And you can see that their favorite hold fast is a tube worm. Well, that's just the same thing, going with years. And